Hello friends, let us start inorganic chemistry course code 332, first chapter molecular orbital theory. It is abbreviated as molecular orbital theory MOT. Now there are 109 more than that elements present, and these elements are combined together and to form a cluster of molecules, and it has the certain bonding between them, and we should know the chemical bonding between the atoms present in that compound. And there are two theories were put forth. One is valence bond theory and second is molecular orbital theory. Now we go to the first valence bond theory and its assumption. First assumption is that a molecule is made up of atoms, and molecule is formed by overlapping of atomic orbitals. Third is atoms maintain their individuality in a molecule. Fourth point, electrons in a molecules are localized between the two bonded atoms. The wave function of the orbital of a molecule is the product of atomic wave functions of individual atoms. So now a molecule is formed by the combination of atoms and to form a molecular orbitals in that molecule. So the assumptions of molecular orbital theory is again, first, molecule is made up of atoms. Second, atoms are lose their individual character when molecule is formed. Third, electrons in a molecule are delocalized. The MO is assumed to be formed by union of individual atomic orbitals. And last assumption, the wave function of molecular orbital is obtained by linear combination of wave functions of AOs. Next is linear combination of atomic orbital principle. It is abbreviated as LCO principle. It is defined as the addition and subtraction of wave functions of atomic orbital is called as LCO principle. For that purpose, we have to consider two atoms, atom number 1 and atom number 2. When the atoms are combined to form a molecule, an atomic orbital can be represented by a letter phi 1 and another atom that has wave function phi 2. So, when these atomic orbitals combine together to form a molecule, at that time it having been denoted by psi. Psi is equal to phi 1 plus minus lambda phi 2. So, lambda represents the ionic coefficient. It measures the ionic character between the two atoms. And now we have to consider the particular wave functions of the atomic orbitals to form a molecular orbital. For that purpose, we have to take the example of hydrogen. One hydrogen atom can combine with another hydrogen atom, gives rise to H2 molecule. There are two types of formation of combinations. One is called as same sign combination and another is different sign combination. So for that purpose, we have to see the same sign combination. At that time, we can represent the orbital is like this, that is of one hydrogen atom having the plus sign, then another orbital having the plus sign, it is of another hydrogen, this is number 1, this is number 2 hydrogen atom, and gives rise to the molecular orbital is like this, and the electron density is concentrated between them in this hydrogen molecule. So the particular equation can be divided into two in additional form, same sign, and another is the different sign. When there is a hydrogen atom having the plus sign, and there is actually here is the summation, here is the subtraction. So like this is the hydrogen having the negatively charged, this is positively charged, and gives rise to wave function like this. So it has the positive and here is negative charge, and this represents the hydrogen. This is called as a bonding molecular orbital, and it forms by the subtraction of the wave function gives rise to anti-bonding molecular orbital. And the equation for this is psi g is equal to g for girate, that is even. At that time the wave equation is like this: phi 1 plus phi 2. This is equation number 2, and this equation represents the bonding molecular orbital. Then second is the psi u. Psi u represents, that is u is ungirate, that is odd, which is equal to phi 1 minus phi 2. This is the equation number 2, and this equation represents the anti-bonding molecular orbital. So in this way there is the subtraction and the addition of wave functions of the molecule takes place. The combination of atomic orbitals, when we consider this hydrogen atom, it has the positive sign, supposed to be the one is AO, plus this is the another orbital which have again the same sign, that is positive, and electron density gets concentrated in between the region that is called as positive charge. This orbital is called as a sigma bonding molecular orbital. Electron density gets concentrated. And now if we see the another example, that is the second, that is positive sign of 1s orbital, and another is the negative sign, and which results into the formation of node-like structure like this. So it has positive sign, negative sign. The MO is formed, that is called as a sigma star anti-bonding molecular orbital. And when we explain the bonding molecular orbital represented by sigma, and another is the subtraction of the wave function gives rise to sigma star anti-bonding molecular orbital. With the help of molecular energy level diagram, we can represent like this. Here this is the energy axis. Here we represent the atomic orbital of hydrogen atom, called to be the AO of hydrogen. This is also AO of another hydrogen, and the atoms and their orbitals are combined to form a molecular orbitals like this. This is represented as a sigma bonding molecular orbital, and this is the sigma star anti-bonding molecular orbital. These are formed by the combination of the 1s of another hydrogen, and this is another hydrogen atom. Its wave function can be represented by phi 1 and another hydrogen. Again we have to represent the wave function phi. These are combined. When we see the hydrogen atom, it has the electron configuration 1s1, and this 1s1, one electron is filled here and another hydrogen over here. These are combined, gives rise to the two electrons in between them, that is form a anti-bonding bonding molecular orbital. An anti-bonding molecular orbital is vacant at the formation of hydrogen molecule. Now we can go to the distinguishing between the bonding molecular orbital and anti-bonding molecular orbital. Bonding molecular orbital is a monocentric, while anti-bonding molecular orbital is polycentric, and it is obtained by the combination of the atoms of the hydrogen, and it has the lower energy, while anti-bonding having the higher energy. And this bonding molecular orbital is having the no node, there is electron density concentrates, while anti-bonding molecular orbital, it has the formation of node, and that is obtained by the particular equation psi is equal to phi 1 minus phi 2. Thank you very much.